Hey everybody, this is Larry. This is day 15, forgot, of the Advent of Code 2024. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's Advent of Code. We have about a minute 20 to go, maybe a little bit less actually. And I'm gonna, as usual, before I forget, just like turn it to this one. And yeah. Yeah. Hope I today I just hope to redeem myself from yesterday. You watched that video. I was at a party for with an open bar. Let's just put it that way. And well, the party went well, but the admin of code did not, and you could see it. So it was kind of fun. But I mean, it is what it is. But you'll probably see it in if you watch the video. It's fun, but we'll see. But today, hopefully, I mean, knock on wood, it should be hard to do worse. So it's all uphill. It's all fun from here. We have 30 seconds to go. So I'm super excited. I refresh and it's already 27. So I guess maybe some timing is a little bit off. But yeah. Stay tuned to the end if you're watching. I usually the first portion is me live solving the problems, and then I try to both upsolve a little bit and go over the complexity and explanation near the end. You can also skip forward. There are chapters I think I've set up. So yeah, all right, 4, 3, 2, 1, go, Larry. Oh, what the? What is going on? Okay, so lanternfish. Need shorter things, but okay. I still don't know what it's asking yet, but I'm just typing out what I suspect I would need. Whatever. Okay. As the world having any boxes in Oswald. However, this actually. Oh, okay. So you have moves and that. Are those one line or? Huh. No, maybe not. Multiple lines. Okay. 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 So yeah. Okay, so then now we are starting at yeah. Okay, so then we did that, right? And then now it's just move, right? So this is where I need to be better about my D4, like my pre-win code. Okay, so up, down, left, right is up, down. Do we rotate anything? I don't know. Whatever. Left, right, right, and then maybe the string is equal to up, down, left, right, right. Okay, okay. So then now, yeah. Okay, what are we doing? So we're trying to push the block. Can we only push one block? Okay, so here we definitely push 2 boxes. Okay. Okay, I mean that's fine. Yeah. If nothing moves, including the robot. Okay, so then now, so it's always attempt to move. Okay. Right. Okay. So then now dx dy is equal to oh, what am I doing? Dx dy is equal to this, right? So we have xy is equal to sy, right? Okay. The inner was in the actual input, but also here. Okay. Okay, so then now, okay. How do I want to do this? Okay, so yeah, okay, so okay, so the only maybe we could generalize it, but not now. I guess we don't have to check for bounds because it's boxed. Okay, so only if this is the case, nx or x y is equal to nx and y, and we're done. Okay. Else, if this should be a switch statement. If this is a thing, then also we don't do anything and we're done. Or we're just done, I suppose. Otherwise, this is the tricky place. If this is a box, right? Then now we want to keep going until we see a dot or a thing. Okay. So then now bx by maybe is equal to y, right? While m of bx by is not is equal to right? Then we just keep going. Yeah. Okay. bx by is equal to bx plus dx, by plus dy, right? So then now this is the first box where that's not the case. So then now if m of bx by is equal to then we can't do anything and we'll break. Otherwise, then it's an empty. Oh, not well. Just continue. Otherwise, which should be in a function, honestly, but it's too late. Otherwise, it is equal to dot, and of course we should actually set m of sx sy is equal to a dot. Okay, so then now so with the dot, then now m of bx by is going to be equal to the circle, the one that we pushed, and then m of nx ny is going to be equal to that, and then xy is equal to nx ny. Okay. I think we're done, but what are we trying to do? The box is one. Sum of all boxes GPS. Okay. So, okay. $100 top edge. Okay. So, okay. For x in range of why am I? Total x times 100 plus y, and that's it, right? Okay, so it's okay. 56. Okay, today we are eating well. Okay, part 2. And turn off the I think acceptable by is twice as wide. What does that mean? Start. Okay, make the following changes. If the ties do. If oh, twice as wide, not okay. That is funky, actually. Okay, so okay, fine. Let's okay, just copy and pasting. Okay, how do I want to think about it? Well, first change this. Okay, I think okay, fine. We just do. Okay, does that work for part 2? No. Oh yeah, it's non-type, but that's fine. And then now here we want to say okay. M of X. Okay, yeah. We'll just parse it. Okay, fine. Okay, so M of XY is okay, so then old is equal to okay, so we have that, right? Oh yeah, and then we just multiply C by 2. That's fine. And yeah, okay. Just remember it, Larry. You have a lot of things to change. Okay. So it's this, then mxy is equal to x is okay times 2, right? Ugh. Come on, Larry. Keep up. Okay, this also should be a switch statement, honestly, but I am apparently terrible now. So okay, and then here we have dot is dot. Okay, that's fine. And then and this is old. I messed up. Okay, so now yeah, this is O. I feel like I have a print quit function, but I don't. Yeah, I don't know. Okay, so then now C. Okay. I guess I could have just copy and paste this one, but if S M of XY is equal to then Sx Sy is equal to XY. Okay, right, and then now M of okay. So we have the same idea, but now we have to update it to do the pushing, right? So okay, so the boxes are twice as big. So you only so what I did with the swap doesn't work anymore. Okay. I should I guess pushing up is tough, right? Oh, that is the tough part because okay, so this pushing is fine, but then going up. Oh wow, actually this is kind of hard. I lied. Going up is kind of hard. Okay, how would I do it? I mean, I think it's just simulation, but it's just a really hard simulation. I think. How do I want to write it? Okay, so if this is the case, then we okay. Focus. I mean, we'll just do it recursively. It's not that big of a deal. But So y is equal to 0. How do I want to write it? Okay. That's okay. That's hard. I don't know if I, this is time. I mean, if nothing else, is a time-consuming one. So, and the difference when you go left or right, is actually a bit easier, I suppose. Okay, fine. We'll special case them out. So if dy is not equal to 0, then we're going left, right. Yeah, okay. We're not going left, right, then we just go wow yeah, then we just do the same thing. If we hit a wall, then we're done. We assert that is right, and then we kind of have to shift everything by 1, which is also fine, honestly. So then we go from nx and y, right? This is kind of hard. The up one is going to be super hard, but yeah. Okay, I'll just write it out. If dy is greater than 0, then we're going to the right, right? So that means that the next cell is that. So then, how do you want us to do the swap, Larry? For if dy, then we have to change this. Okay, so for current y in range from by is the place, and then ny by -1, right? Inclusive, I think. M of b cy, well, and x and y. Yeah, I mean, I think this doesn't change anymore, but so that is equal to m of nx. It's gonna be by, so this is this -1, so then this is going to be, and we don't know, yeah, cy plus 1, right? Okay, yeah. I have to make some changes to this so that I could be a little bit easier. Okay, I need to do a print function too. Okay. Yeah, I think this is right, but right-ish. The other way. Okay. So then now we should be able to run this on part 2. It doesn't do anything. Okay, fine, because I didn't print anything. Oh, well, it doesn't do anything anyway. But yeah. Okay. So we have a print function, right? After her thing, right? So for x in range of O, for y in range of C, print m of xy. Right. So then now let's just say we print after everything. I guess it's fine, right? Okay. Oh, that's because it's the. I just want to run it on test. Is that right? I don't think so, because we have 3 boxes and we ate some of them. Which is definitely not good. And also we do this 3 times, so that's weird. Right? Okay. Let's just print in the beginning. Oops. In case that we skip doing it. Okay, so we just ate one of these. Okay, that's not fine. dy is, no, this is should be right. cy by is the so it is a period, right? So alright, I don't know. This is gonna be an annoying problem anyway. So yeah. Why doesn't the first 3 things like push it? Oh, because of the extra space. That's right. Oh, also reducing xy here is kind of risky, but I mean, we did top 100 once today, so like even if I don't get it, I'm actually pretty okay. I mean, could I be okayer? Yes, but I'm also okay, you know. Okay, so and then he just ate it, ate it. Maybe why? That's not right. Am I doing it the wrong way? Why? Huh. By minus 1 should be. So this is the period. Why? Why is that wrong? Nx and y. I mean, x is the same anyway, so it's not nx should not be any different. I mean, it's moving. It's just not Gucci. So okay, so here I did this, right? Yep, it does it. It's here. BYY, I don't know. 10.7, right? So yeah, huh? I guess there's a period. Yeah. Did I mess this up? I guess I went in the wrong direction, maybe. Yeah, I did, huh? I am dumb. Okay. Okay, so that push is good, right? And now we want to try the other. Well, we just, I guess we might as well just keep pushing to see what happens. Whatever, it should be okay. I know that I go out of bounds. Okay, maybe I cannot go out of bounds. Oops. Okay, so now we're pushing. Okay, Larry Pusher is happy. Okay, so you got one of the 4 directions, the easiest one of the 4. But okay, you know, everything starts with the easy ones, and then it just gets harder. Maybe. Okay, so this should not do anything. Okay, it just eats stuff. I eat little coat like you for Christmas. Something like this. Trying to keep it friendly, of course. Okay, so I think this part now should be easier because I already made the silly mistakes. Maybe. Also, I have visualization. Power of visualization. We got this. We got this. Nope, still ate it. Am I doing the right direction? Negative. Oh, right, whoops. Copy and paste mistake. Still wrong, but hopefully that should be a little bit better. I mean, I knew it was wrong, but Nope. I'm just being lazy. Think, Larry. Use your brains instead of brute force testing. Okay. Okay, so then now, okay, let's just print just to make sure. I mean, we got part 1 right, so that should be okay, right? Okay. So then now, we want to print CY to BY, Y to BY, right? 11 and 9. Sounds about 14 to 9. That sounds about right. So we want to do the first cell. No, that shouldn't be that here, right? The first cell is the smallest number, which is not Y. Y is bigger, Larry. Come on. Come on, Larry. Okay. Now, yes, there you go. Push as hard as that map character. Push it all the way home. Okay, push it out of bounds is probably no bueno. Oh, the reason why I push it out of bounds is because here somehow we... So oh yeah, so okay, so this is nope. That's actually muy malo. How did I do the other one right? I hope so. I guess we'll double check it. But okay, we push, and then, but there's a space. That's fine. The space is at by, and then we by. Okay, yeah, okay, I see. Okay, so now we're Gucci. I think this actually is wrong, but now we're Gucci. Okay. Off by 1 errors, always hard. Okay. Just want to double check. So here we'll just keep going. Probably have a smarter way of doing this. Okay, fine. Okay, so we're okay. Okay. Okay, so we got the easy parts done. Yay, go us. And then now we have to go else. This is hard. How do I do it? And also, I think the answer is actually just a laugh bracket, right? But how many people have gotten this already? I'm just kind of curious. Only 34 people have gotten it. Very impressive, 34 people. Okay. Well. Okay. So let's say if we're okay. So then now bxby, right? So then now we want to calculate okay, so okay, fine. Just you know what you want to do, right? So go. We want to say go xy, right? So yeah. Okay. If done is equal to a set, say, and then now if cxcy isn't done, then we just return. Otherwise, do a connected components thing, but not really. Otherwise, if m of cxcy is equal to if it's the left side, then we want to go yeah, okay, actually, yeah. If m of okay, so return true, I guess. Right? Or maybe something like okay, yeah, we'll just have a user global thing. Screw it. Right. Okay, then if this is this, then we go cx cy plus 1 to go to check the right one, right? If we go to cy minus 1, right? Of course we want to done that add cx cy, right? Okay, and now what do we want to do? We also want to go to the dx, right? So okay, so oh yeah, we have to check the other ones, I suppose. Cy is equal to then we just return because we're good. We don't care about it yet. Otherwise, if m of cxcy, I really need to be better about switch statements. Are these the only cases? Yeah, I think so. I want to say so. If this is equal to this, then good is equal to false. Return, right? And otherwise this is good. Ooh. Oh yeah, if this is the case, then we also want to go check the dx. So plus dx. Okay, that's fine. so that we go up or down depending on that one. So then now this should give us all the recursion from the thing, and whether that is good, right? So go we already assumed that this is a thingy, so it should be good. So go XY, right? If good, yeah, just print good. I don't think it's that hard actually now, but I'm just trying to. I should kind of come up with cases first, right? Okay. So then now you have something like this. Let's just say you go up. Well, this should trivially be good. Non-local what? Oh, how did I just forget half the things I was saying? Okay, so it doesn't even print good or no good, which is actually pretty no bueno. Oh no, because I don't have a box. Okay, so it's good, good, good. Okay, fine. Let's say we have another box, then it still thinks it is good. Why? Let's say done, right? 314. I assume that's this one, but then why not 314? Am I doing this wrong? No. So, why does it not check? Okay, let's check M6. Okay, so it's a dot. That is just wrong, right? Do I do a loop here somewhere? Oh no, I want BXBY, not XY. Whoops. Yeah. Okay. Correctly no good. Let's double check that this is good. Okay. Let's actually also add a what the okay. And then we also want to add bottoms, say, right? Well, I don't do anything. This thinks that bottom going down is good, which is not great. Oh no, it is good. So we have to add a thing, right? Okay. Okay, you're almost done, Larry. So if it is good, then we just move everything up or down one, right? So yeah, okay. In theory, if it's no good, print no good, and then we just continue, I think. Maybe we could print out debugging thing, but okay. So then now, oh yeah, it's just as easy as doing whatever you're saying, right? Okay. Yeah. Okay, so we assume that these are good. So then now we just do for XY in sorted list of done. That works, right? I'm not dreaming that. Okay. Then now we want to say I'm gonna say x of, so now we have to check. Okay, we have to check whether x is okay. Whatever, just do it, Larry. If dx is not equal, if it's greater than 0, then dx is. So then now you go from the copy the bottom up first, right? So then now m of x plus 1 y. Also, this is terrible. Shadowing. I hate shadowing. Is equal to m of cxcy. So okay, so these are formally things, right? So then now m of cxcy is equal to right? So then we want to assert m of cx plus 1 cy is equal to dot, right? I think maybe this works. Well, we didn't push, so no Gucci, but Oh, I think actually we didn't. Okay. Well, I guess we could add another line actually, so I could look at that real quickly. Okay, assertion error is wrong. Why? What is it? That should be right. So for a current thing, you move it down one, right? Yeah, that should be right. Why is it wrong? Oh, left bracket. No, we should have moved it. Oh, this is the part where I got confused. No, you dummy. Yeah, you're sorting it wrong. Okay, still wrong, but the assertion is still wrong rather. But why do I don't have a print statement? Okay, there you go. Print. Dong dong dong. Where is it? Why would it be 7? Let's see, 0, 1, 2, 3, 4, 5, 6, 7. Why? If it's period, it's not. Oh, cause yeah. Okay, we need to do this first. And then also this, I suppose. So then that done actually only. Okay. Okay, so that get pushed down. We're almost there in theory. We want to. Yeah, I mean, okay. I don't know. I'm gonna YOLO submit this after. Even though we probably could test this a little bit more, but I feel like testing is gonna be a minute anyway. If it doesn't work, so we might as well YOLO. But okay, so here. -1 I think is right. Okay, so then now we can bring back the sample that we kind of removed. 8102, tell me it's right please. Oh, 9021, so that's definitely not right, but we do actually print stuff. Okay. It is definitely way wrong. Okay, well. Okay, well, we're definitely way wrong. A lot of boxes are all over the place. But we can also just check. Okay, oh, this one is maybe a better one to play around with. I think we're not on the leaderboard already, but that's fine. This is a fun. This is a hard one for sure. Okay, go down, push. Oh, I push, but then I don't update my location. That's why, maybe. That's true though. That it is something that I did not do. XY is equal to NXNY. Okay, maybe that should be it. 618. I don't know if that's true. Now we have to copy paste the other one again. I need like a better way to do multiple small examples. 9021, okay, let's go. Maybe I didn't need to print all these, but okay, definitely did not need to print all these. Come on, get rid of the print, okay. Okay. 249. Huh, people are really fast on that one then, I guess. I mean, I maybe not really fast, but I was very slow on this one. I thought I had more time, but oh well. I mean, I'm not going to complain too much. That was wow. Half an hour is actually kind of slow, honestly. Like I knew what I wanted to do, but I was just. I mean, I don't think it's that hard. It's just that I think I spent too long on this one, trying to think about a clever way of doing it when it's just like a grind problem. And I probably could have grinded out more, and I didn't really trust myself enough. Yeah, I think that was the big thing, was that I didn't trust myself enough for to kind of go. So I was like going way slowly, and that's probably not the way to go, honestly. Like if I wanted to get on the leaderboard, I should have been just YOLO it more. But like given it, like I feel like I mean I'm only 5 minutes off. I mean like I don't know how. Yeah, I guess a lot of 5 minutes is like, you know. But I mean, I don't feel that bad about this one in the sense that, like, well, I think strategy wise, I could have been better because I feel like if I'm 100 or 249th, if I had just got one wrong answer and then have a, like, I got one early wrong answer because I code too fast, like, then at least I know I would have tried my, like, strategy wise, that's probably more optimal than not getting, like, I didn't get any wrong answers, but I also, you know, was too slow, right? So it's the same as moot. But yeah, okay, let's go over the problem real quick. I mean, I think in terms of understanding, the example was actually really good on this one. Like in terms of illustration, I think I could be wrong, but we'll go over the code real quick. Actually, let me see. I did finish top 100 on part 1, so that's always good. I'm just curious about the times real quick. So where's Larry? 8 minutes. Ooh, whoops. 8 minutes. I don't think I could have been that much faster. Clearly, there's still some ChatGPT people, but I don't think I could have been that much faster. Like if I was maybe like I didn't think I was that fast either though. But I mean like, you know, like if I was 20 seconds faster, okay, fine. Maybe I could have been slightly faster. I don't know. But either way. We'll go with the code. Yeah, so I think the key thing to note is this idea of a swap for part 1, right? And what I mean by that is, I'm gonna break out the drawing board real quick, actually. Hang on, friends. Breaking out the drawing pad. Because I feel like people don't like my ASCII art, even though I feel like it's so much easier. But okay, so yeah, so the idea here is that the key implementation idea, and I think you don't even need it. You can just do like a for loop if you really wanted to. But the key idea is that if you push, I think I used the wrong things. Okay, so this is Larry, right? So let's say you push. Oh, I think boxes are circles. Okay, fine. Is it? Hang on. Friends. Technical difficulties. That being me being dumb. That's the technical difficulty. Yeah, boxes are which is actually kind of confusing, huh? Well, okay. So maybe I'll okay, fine, right? So the key, the key observation is that, and this works in every direction, obviously. So I'm just gonna say without loss of generality, I'm just draw a person. This is a box, right? And there are boxes, and then maybe empty spaces, right? Well, the two things is that if you just kind of do a scan in that direction, if the first thing you see that's not a box is a period, then you have room, right? If it is a wall, that means that you don't have room, and that's basically the idea. If you have a wall, then you know, do thing. In terms of simulation, you can obviously just code it so that you kind of move it one at a time. But the thing that I noticed was that you can just move this box. You could just move this box all the way over here and saves you some time in typing. And that's basically what I wanted to illustrate. And that's really it. Maybe I don't know. Let me know in the comments whether I needed to drawing, because I feel like sometimes I don't draw enough. So we'll see. But yeah, and that's basically what my code, everything's on screen, kind of goes for. I have up, down, left, right. There's this thing, right? And then I find the starting point. Again, I use this thing called to infinity grid, but it's just like a map of a map. So it's a lookup table of a lookup table with a default dict. So I don't know. It just lets me get out of bounds without worrying about getting out of bounds. Though for this one, I didn't have to worry anyway. But yeah. I probably could have merged the lines. Oh, yeah, I also have this thing called get separated inputs. It's a common thing for like when I have two blocks, what I call them blocks separated by empty lines, then you could do it that way. I mean, it just saves me a little bit of time. But yeah, but for the processing for C in line, we have dxdy. We look it up by the index according to this up, down, left, right, which corresponds to the dxdy. So dxdy is equal to the thing. So this is just a very quick way of parsing the instructions in the second block. And then we just look at the new cell. If the new cell is a period, we just we just move there directly. If it's a wall, then we just don't move. Otherwise, if it is a box, we just keep, as we said, we just kind of scan in that direction until we see something that's not a box. And when we see something that's not a box, if it's a wall, then we don't do anything. Otherwise, yeah, we swap like we talked about, and that's pretty much it. It's pretty straightforward. And then for for the print, it's, I mean, you know, I feel like this part is pretty straightforward as well. It's just the format that they give you in the problem, right? Okay, part 2 is a lot harder. I'm not gonna go over it in too much detail, or rather, I'm not gonna go over the problem in too much detail, in the sense that you know, I feel like the for part 2, this is actually, oh, not this one. For part 2, you know, like they kind of showed you all the, I don't know about order, but like the really big edge case that you might have to consider, right? And I think that's, you know, as long as you kind of think about that, that's fine. For me, I kind of, I don't know, but we'll get it down to case analysis, really. So first, oh, I had to show you the code. So first, maybe I can move this down here. Mostly everything's the same. The top part is just doing the conversion, right? So all the top part is saying is just converting to a double-sized grid, which is, you know, given to you in the input, or given to you in the example, right? What to do and how to double it, or in the problem statement, if you will. Yeah, and then you double the columns, and then yeah, and then just again you find the starting block, you set it to a period, and I'm not going to rehash this part. It's just up, down, left, right mapping. I actually did have a helper print function just in case, but yeah. And honestly, I felt like I probably could have gone a lot faster this part. In retrospect, I was going very slowly because I was really careful. But the idea here is just the key idea is just figure out which blocks you have to make move, right? And I kind of broke it down to case analysis as well for this one. Again, if the new cell that we move to is a period or a war, a hashtag, we just ignore it, right? Or, well, on a period you move, but yeah. Otherwise, if it's one of the boxes, and you can maybe even assert that, then there are only 2 cases, dx and dy. Oh, sorry, move left or right, or up or down, right? And those are 4 cases. I guess you can kind of mix them together, but you get my idea. And the idea for moving left and right is basically the same, right? Left or right is same as the other one. You just kind of push everything over. And in this case, I guess it's kind of funny because as a result of doing that optimization in part 1, where I move 1 cell, I don't have the code ready for part 2, so I have to kind of write this for loop slowly. And I was kind of verifying it on my own examples, right? So yeah, but this is what it is. It just shift everything off by 1. I think the more interesting part is the up-down part, right? And here we have, and the idea here is just recursively look at every cell that we have to care about, and the cells that we care about are boxes, right? We care about boxes, and that's it, right? And what that means, what does that mean? So here there's this function, we've always seen it so that we don't kind of go back and forth in the same box or something. If we see a period, then we're done. If we ever see a war, that means that, because we're all, the invariant about this function that we want to do is that it's always boxes. So when you don't meet boxes, then you're kind of out of bounds in terms of the boxes, and that means that you will always be either a period, which is a free space, or a war, which is not, right? But if you see a war, that means that the previous cell is a box, and thus, if you see a war, that means that you cannot go. So I just kind of have a global-ish function, or global-ish parameter, or variable, I can't even get words right, variable, where I said, okay, well, that means that is no bueno. If we see a war, that means that something is being blocked, and that's it. Honestly, in retrospect, I kind of, in my head, I thought it would be way more complicated, so I didn't speed it as fast as I would like, because I was kind of going through it, but maybe I could have been a little bit faster for sure. But yeah, the tricky part is maybe this part is that, okay, well, if it's the left side of the box, we want to scan to the right side of the box, and that's what this is for. And if it's the right side, we go to the left. In both cases, we want to go up or down depending on the dx. that dx, of course, it depends on whether we're going up or down, right? So that means that if you have it doesn't matter if you're the left or the right, you just go to the next cell from that, and that will calculate whether we're good. And that's pretty much it. I mean, yeah, so we call it, and if it's good, then everything. The key thing about our go function is that we also keep track of things that we're done. But done is probably a terrible variable name. It is actually also the everything in done. And if you watch the live portion, if you did anyway, you'll see me kind of move some if statements around to change the invariant. Initially, the invariant is just that done. All the cells that we visited, no matter what they are. But the reason why we changed the invariants is so that done only contains boxes. And as a result, then now we know all the boxes that are in the set. So then now we can just do it for each box for each component of a box. We just move either up or we move it down, depending on obviously the input, right? And that's pretty much it. The only one more maybe tricky thing is that to make sure that you do in the right order, you want to sort it by technically only the x value, right? And I even reverse it when I go from down for pushing things down, so that you kind of make sure that it's like a shifting thing, right? You could kind of work this out, I think. And yeah, otherwise, if you do it the other way, then you just overwrite things before you get to move them. So that's why. And then at the end, I don't think I even changed this code. Actually, I lied. I definitely changed this code. I changed this to kind of check the left box, and that's pretty much it. Let's go. I guess I didn't go over the complexity. And the reason why I didn't is because for part 1, it is linear, right? For each instruction, we only do... Oh, whoops. Sorry. For each instruction, we only do all of one time, so pretty straightforward. For part 2, it's a little bit trickier. Yeah, for each instruction, we definitely can... Oh, actually, I lied about the previous one, because we do have a for loop. I forgot about this. In theory, you can optimize this if you really want this for loop, because you can either do a binary search, or you could do a lookup table, dynamic lookup table kind of thing with updates. It's a little bit tricky, though, but in theory, you can maintain the next empty cell or the next row or something like this, and that'll kind of get it to you. But yeah, I don't know. It's obviously not worth doing for time purposes, but you can definitely obviously practice upsolving. For part 2, yeah, there are a lot of loops, and in theory, the number of boxes could be taking most of the graph. So in theory, this is going to be for each instruction, we can visit the entire graph. So that means that, well, it's gonna be I times n, where I is the number of instructions, and that's that as well. Which is fine, right? Because at worst we're looking at every cell, and when we look at every cell, then it's linear, right? Yeah, which is fast enough. So I'm not complaining. But yeah, that is all I have with this one. The explanations and everything. Hope everyone did well. If not, I don't know why I said it like that. If not, there's tomorrow, I guess, for both me and you. But that is all I have with this one. Thanks for the watch. Thanks for hanging out. But yeah, stay good. Stay healthy to good mental health. Hit all the like buttons. And yeah, I'll see y'all later and take care. Bye-bye. And hopefully see you tomorrow.